Hi everybody. Now we're going to quickly do number 2, which is similar to number 1 in that we still have a platform, a cannonballer, and a target, and the cannonballer is still launched at a speed of 15 meters per second, but now what's different is they are being launched up at an angle of 53 degrees to the horizontal. And we want to figure out, the people who have to set this up for the next act have forgotten how high to make the platform and how far away to put the little target. And so we need to determine that. They do conveniently remember that the whole trip took a time of 4 seconds. So let's remind ourselves what's going to happen. Cannonballer is going to travel up. Let me do a better job of that. Cannonballer is going to travel up and then down on a parabolic trajectory and hopefully land on a target if we do our job correctly. Okay, and we have an initial speed of 15 meters per second. Now, the first thing we're going to need to do is deal with that angled velocity. So let's come over here. Let's redraw it nicer so that we can really decompose that 15 meters per second into a horizontal Vx and a vertical Vy initial. And we know this angle here is 53 degrees. We can use our trig functions. Cosine 53 is Vx over 15. To get Vx. And then we can use, which is going to be, let's see, 9 meters per second approximately to the right. And then we can use sine of 53 degrees to get Vy initial, opposite over hypotenuse. And that gives us that Vy initial is 12 meters per second up, so positive 12 meters per second. And just like the last problem, I'm putting 0, 0 down here, and positive is to the right, and positive is going to be up. Okay, so we want to figure out the y initial, so the initial point here, and we want to figure out the x final, how far away this target should be placed. All right, so let's do our little charts again, known and unknown for the x direction. Well, I know now from what I'm doing here that my v initial x, my vx, because it doesn't even need initial because it doesn't change, is 9 meters per second. I know from the problem that I'm in the air for 4 seconds, and all I need to find is my x final because my x initial is 0. So here I can actually figure it out in one step. 9 meters per second times 4 seconds is going to give me a horizontal position of 36 meters. So I know I need to place my platform 36 meters away. Now I want to figure out how high the platform needs to be to make this all work out the right way. And so known and unknown for the y direction again. My y initial is what I want, so I don't know that. I do know I'm landing on the ground. I know my acceleration is negative g. My v initial y is no longer 0. Now I have this upward component, so it's positive 12 meters per second. I don't know my impact velocity, v final y, and I don't care. And I do know that my time is still 4 seconds. So again, I can use my equation number 2 from the big 3, y final equals y initial plus v initial yt plus 1/2 at squared. 0 equals y initial plus, now this isn't 0, I gotta be careful, 12 meters per second times 4 seconds plus 1/2 times negative 9.8 times 4 seconds squared. And I work all of that out and I get that y initial is 30.4 meters. Okay, so now I know how high to make my platform and how far to put my target. The last question this asks you is, how high does the cannonballer get? What's going on at the top? And you have to remember a few things to solve this part. First, you have to remember that at the top of a projectile's trajectory, at the top of the parabolic path, momentarily it's only moving horizontally. So the only velocity that persists at that moment is the Vx, in this case 9 meters per second. The Vy at the top is 0. For a brief moment, it's turning around, so it's neither moving up nor down. It's just briefly paused vertically, just like a rocket at the top of its path. Okay, and we want to know this maximum height h. And now we also know that our y initial over here is 30.4 meters. Okay, so let's come down here and let's see what we can do. So let's make another known and unknown chart because it'll help us be a little more efficient maybe, and at some point maybe you won't want to do these anymore, but I'm going to do it right now just because we have a couple minutes. So I know my y initial is 30.4. My y final is this h, that's what I want. I know my acceleration is still negative g. I know my v initial y is 12 meters per second, and I do know my v final y is 0. I don't know how long it's going to take me to get to the top. Now, I could figure that out and then plug it into the big three, equation 2 of the big three, but I'm going to be more efficient and use the equation that doesn't have time in it. V final squared is v initial squared plus 2a y final minus y initial, v final y, v initial y. So v final y squared is 0. V initial y squared is 12 squared plus 2 times negative 9.8 times y final, which is the height I want, minus 30.4 meters. And if I go and I do all of that, I wind up with y final equals 37.7 meters above the ground, so about 3 more meters above the top of the platform. That's it. Hope that was helpful. Bye.